What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our lesson 3.8 and we're going to focus on day 2 of this. So we already know what parallel lines and perpendicular lines in slope-intercept form and point-slope form are, and now we're going to put that into some action. So we're going to be able to classify lines as parallel, perpendicular, or neither by comparing equations of lines, and also classify lines as parallel, perpendicular, or neither by comparing the slopes of their lines. We're going to get started with the first two things on your list, and those are slopes of parallel lines. So slopes of parallel lines are, I'm going to go ahead and just type this, it's a little bit easier, two lines that have the same slope are parallel. And then all vertical lines are parallel too. So some examples of what that would look like here. Vertical lines, these are both going to be parallel. These technically have an undefined slope, but they still have both the same undefined slope. Or maybe we have some parallel lines looking like this, and we can say that their slopes are 2/3 for both of them. Okay, so that would mean that they are parallel. The slopes of perpendicular lines, though, those are going to have two lines that have opposite reciprocal slopes are going to be perpendicular. Okay, and this is what I mean by that. Say, for example, we have one line, slope A is equal to 1/4, and then slope B is equal to -4/1. So notice that we have just taken that fraction and flipped it around and also made it your opposite reciprocal. So say, for instance, we have these two slopes. Let's say this one is 4/5, but then this slope right here is -5/4. That is going to prove that those two lines are perpendicular. Okay. Another way you see this is if you have 4/5 and you're multiplying it by -5/4, you're going to get -20/20, which is equal to -1. You want their slopes to be the product equal to -1. Okay, and that's going to prove that their slopes are opposite reciprocals. So changing the fraction, just flipping the numerator denominator, is essentially like the easier way to understand that, and making one of those a negative, the other positive. Let's go ahead and try example 1. It says determine whether A, B, and CD are parallel, perpendicular, or neither. So I'm going to find the slope of AB, and then I'll find the slope of CD, and then see if they are fitting in one of those categories. For AB, I'm going to do my y's first of 2 minus 6, and then because I did 2 minus 6 this way, I'm going to do -9 minus 3 for my x's. 2 minus 6 is -4, and -9 minus 3 is -12. That'll just end up giving me a positive 4/12, and then that reduces to 1/3. So AB's slope is 1/3. For CD, I'm going to do 3 minus 4 for my y's, and since I went here to here, I'm following that suit and going 2 minus 5 from here. 3 minus 4 is -1, and 2 minus 5 is -3, and two negatives in fraction form end up being a positive. So we can say that these lines are parallel because they have the same slope. Okay, let's go on to example 2. See if you want to try this one on your own. So if you want to pause here, try it, and when you're done, click play to check your work. All right, so we're still determining if AB is parallel to CD. So AB, I'm going to say 0 minus 13 for my y's, and -11 minus 14 for my x's. 0 minus 13 is -13, and 11 minus 14 is a -25, and that's just going to simplify to be positive 13/25. So in order for CD to be perpendicular, I would need -25/13, or parallel would need to be the same. So CD, I'm going to say -5 minus 7 over -4 minus -3. Remember, I'm doing slope, I'm just doing y2 minus y1 over x2 minus x1. That's going to give me -12, and a -1, which is just equal to 12. So I would say neither. Okay, there is no slope relationship. Okay, next we're going to flip the page, look at a picture now. You can either count rise over run for this, or just use your same y2 minus y1 over x2 minus x1. Be careful though, because your intervals are going up by 2. So 2, 4, 6, 8 is what we're seeing for our interval. So if I'm trying to find rise over run for RS, here is R and I'm trying to go to S. So I'm counting up by 2, 4, 6, 8, 10 is my rise. And then my run, 2, 4, 6, 8, 10, 12, 14. Or reduced down to be 5/7. If you don't want to count rise over run, or if you need to double check your work, 7 minus -3 is my y's, that gives me 10, and 6 minus -8 gives me 14, that's my x's. For TU, my rise and run are going down, so rise is 2, 4, 6, so -6, and right away I can probably say neither, because I'm already seeing no commonalities in that number. My run is 2, 4, so that's -6 over 4, which is -3 over 2, and that one would also be considered neither. There's no slope relationship. Okay. Second part of our notes, now we're going to look at some equations and determine if those equations are parallel, perpendicular, or neither. But before we do, we're going to review some slope-intercept form. We have y is equal to mx plus b, where m is the slope and b is the y-intercept. Okay. Point slope form says y minus y1 is equal to m parentheses x minus x1. M is still the slope here, but now x1, y1 are points included on that line. A vertical line is up and down, looks like this. So we're going to say that can be represented by x is equal to a, where a is the x-intercept, so where it's crossing the x-axis, and a horizontal line runs left to right. We would see those equations as like y is equal to b, where b is the y-intercept still. Okay, so make sure you have that copied down. When you're ready to keep going, let's go ahead and take a peek at example 4. Example 4 says determine whether these lines are parallel, perpendicular, or neither. The first one I can easily spot my slope because it's in slope-intercept form, and even this one I can spot my slope because it's right here as my letter M. And notice these are opposite reciprocals, so I would be able to say that this is perpendicular because they have opposite reciprocals. Or when I multiply them, 3 times -1/3, my answer is going to be -1 as my product. Okay. Letter B, these are also going to be perpendicular, because if you remember from before, x is equal to 1's here, so that line is a vertical line, and y is equal to 3 is a horizontal line, and all vertical and horizontal lines are going to make perpendicular lines. Okay. Next up, we're going to see determine whether each pair of parallel lines is perpendicular, parallel, or neither. This is when it'd probably be helpful to put in slope-intercept form, because that would be the easiest one to determine from here. So looking at letter C, I have two different ones that are not in slope-intercept form, so I'm going to start with that first one. Y minus 5 is equal to, I'm going to go and distribute -3 to the x and the 2. So -3/4 x, and then -6/4, or you can even say 3/2. And then I would add 5 to both sides. And I'm trying to look back at my notes here. I can even really stop here because it's going to be able to show here's my slope, -3/4 x. So the second one, I have 3x plus 4y is equal to 16. I'm going to get y by itself so I can at least identify what my slope is going to be. So I'm going to have 4y is equal to -3x plus 16, And then when you divide both sides by 4, I'm going to get y is equal to negative 3/4 x plus 4. Because remember, when we're dividing by 4, we're dividing everything here. And if you notice, both of my slopes are the same, so we're going to say parallel. Okay, so putting it in slope-intercept form or point-slope form is an easy way to identify your slope. So here in letter D, my slope is here for number 2. And here, my slope is looking like it's 1/2 x. I'm still going to distribute just so you can kind of see what that would look like, because we're going to get some practice with that. So if I distribute my 1/2 to the x and the 2, I get 1/2 x plus 1. And even if I add 1 to both sides, you can still see your slope doesn't change. 1/2 x plus 2. Here's 1/2. This one is 2. So this relationship is neither. There's no relationship between slope. Sorry for the bell. Recording after school now. Example 5, though, is now going to focus on writing equations in slope-intercept form to a parallel line, which just means I want to have the same slope listed here. So parallel slope I need to have is negative 3/4, and then containing the point negative 3, 6 would need to be x1, y1. So I'm going to use point slope form to help me. Point slope form is probably the easiest one to use here, so let's go ahead and do it. Y minus 6 is equal to my same slope, negative 3/4, and then x minus negative 3, which would be x minus 1. I'm going to change that to x plus 3 and go ahead and distribute because I need this in slope-intercept form. So y minus 6 stay in put for now. Distribute negative 3/4 to make it negative 3/4 x minus, and because I'm distributing a negative 3/4 to my 3, that's going to be negative 9/4. I like mixed numbers, so don't come at me. I'm going to change that to 2 and 1/4 because my next step is to get y by itself, and how I do that is add 6 to this. So y is equal to negative 3/4 x, and then negative 2 and 1/4 plus 6 is going to be 3 and 3/4. So there's my equation in slope-intercept form, parallel to that line already containing negative 3, 6 as a point. Next up, we're going to do something similar, except now we want a perpendicular line. And notice that this is not in the form of y is equal to mx plus b, where I can easily see my slope. So let's go ahead and get it there. I'm going to subtract 4x from both sides. So I'm going to have negative 5y is equal to negative 4x plus 10. Divide both sides by negative 5. Sometimes it might be easier to show everything being divided by negative 5. That way nothing gets left out. So y is equal to a positive 4/5 x minus 2. So here is my slope. And again, if I want a perpendicular slope, I'm going to do the opposite reciprocal. So negative 5/4. And I'm going to use negative 4, 4 as my x1, y1. Okay? So y minus 4 is equal to negative 5/4 parentheses x minus negative 4, which will eventually change to x plus positive 4. Let's go and distribute my negative 5/4. So I'm going to get negative 5/4 x, and then negative 5/4 times a positive 4. That is going to give me, let's see, we can show some steps over here. Now my brain's freezing. Yep, negative 5, so minus 5. Okay. Then I need to add 4 to both sides to get y all by itself. So my final answer would be y is equal to negative 5/4 x minus 1. Okay. Last one is what happens when you are not given your slope at all, but you want it to pass through the point 2, 4. So that's still your x1, y1. Perpendicular, meaning opposite reciprocal, and then this line containing these digits, or these coordinates, I need to find the slope of this line first. So I'm going to do negative 6 minus 7 over 7 minus 8. Okay, negative 6 minus 7 is a negative 13. 7 minus 8 is negative 1. So my normal slope is just 13 over 1. So my perpendicular slope would just be the opposite reciprocal, negative 1/13. Now let's use x1 and y1, which is 2 and 4, to plug that into point slope form and then put it in our equation. It doesn't say what type of equation, so we'll give 2 answers for this. So point slope form could be y minus 4 is equal to negative 1/13 parentheses x minus 2. So that's one way point slope form. And then if you wanted to put it in slope intercept form, you could distribute negative 1/13 x plus 2/13. And then for to get this in slope intercept form, I'm going to get all my y's by itself. So I'd add 4 to both sides. I'm going to get y is equal to negative 1/13 x plus 4 2/13. Okay, so here is slope intercept form and point slope form. So either one of these would be correct, just because it didn't say to indicate what type of equation. Thank you for hanging in there with me and tuning in. That'll conclude our notes today on parallel lines and perpendicular lines. If you were confused about what we talked about today, maybe check out 3.8 day 1, and that's when we take a little bit more time to talk about point slope form, slope intercept form, and how to find slope. Hopefully this video helped you, and we will catch you next time on the next one. Have a great day.